In the previous videos, we were doing binary classification where there were only two possibilities. Like in this case, it was false, not addly, or true, it is addly. Let me show you an example where there are more than two classes. So let's create a new logistic regression object. Okay, so this will be logistic regression. Okay, I named it CLF again. And then this time CLF.fit. Okay, let's go ahead and again use build length. Okay, but instead of using this is addly column, let's instead use the species column. Okay, great. And let's put a new prediction column into DF. So let's call it pred4. And this will be clf.predict. And then we're only using the build length. And so if I look at the top of this data frame again, and I go all the way to the right, you can see that instead of predicting some like integer or float like this one, or instead of predicting a probability like this one, now the prediction is this string. So this is an example of like, there'd be no way to get this kind of output using regression. Okay, even though it's called logistic regression and regression is in the name, this is very much a classification style of supervised machine learning. And the evidence that it's classification instead of regression is that the outputs are these like discrete strings as opposed to different numbers or numerical values. So like, let's look at what are the different strings that show up in this pred4 column. So I'll use value counts. Okay, I could also use unique if all I wanted to know was which ones occur and not how often. So using only the build length, it doesn't seem to do a very good job because it's not getting very many chin straps. Whereas if I look at what's actually in the species column, then you can see there are many more of the chin straps. There's 68 as opposed to 10. Okay, and in terms of like, how does this data look? So alt.chart df. Let's do a scatter plot again. So mark circle dot encode. And let's have x be the build length like usual. Let's have y be, how about flipper length? So we haven't used this so far anywhere. And let's say color is equal to the species. And so what are we doing here? We are trying to only use the build length column. Okay, we're trying to only use that to try to decide, is it addly, is it Gen2, or is it chin strap? Okay, I definitely might be pronouncing those incorrectly. And so we can probably do a pretty good job of distinguishing addlies, okay, because you can see they are sort of off on their own in terms of like the build length. But okay, we're not using the flipper length at all in our classification. And so it's pretty hard to tell, like, for example, say I tell you that the build length is 50, and you're supposed to predict, is it addly, is it chin strap, or is it Gen2? Well, you can really easily say, okay, I don't think it's addly, but how would you decide, is it chin strap, okay, or is it Gen2? And probably what the model is doing is it's probably predicting Gen2 because there are more Gen2s than chin straps. That's my guess. And so we can check the accuracy of this by using a method called score. So clf.score. Okay, and then I say, what were the inputs? Okay, so that was the build length again. And then what were the true outputs? So the true outputs were df species. And so this is saying it had a 75% accuracy. And if I look at clf.predict, instead of predict, do predict proba for predict probability. And this df, again, input is bill length. So now this is 300 or whatever by 3 NumPy array. And what do these things mean? So this is saying, well, there's a 98.7% chance it's some class. There's a 0.002 probability that it is some other class, and there's a 0.0108 probability that it's another class. And so how do you know which class is which? I think it's always alphabetized, but let's check. The better way is to look at this classes attribute. So this is like saying for the first input, it's a 98.7% chance of Adelie. It's a, let's say I can't convert to percent in my head, so it's a 0.002 probability of Chinstrap, and it's a 0.01 probability of Gen2. And we could make our classifier more accurate by using multiple inputs. So remember that up here we had a 75% total accuracy. And I could do CLF, or let's do CLF2. Let's make a new one. Okay, this is a new logistic regression. Okay, and then CLF2.fit. And now let's use two different inputs. Let's use bill length like usual. Okay, but now let's also use flipper length. And so looking at the Altair chart from up above, it does seem like if you're able to use both of these, both the bill length and the flipper length, then you should be able to do a pretty good job of distinguishing between these three classes. And let's check. Okay, so those are the inputs. Now there are two inputs. Output is going to be the same. Output is going to be species. And let's check the accuracy of this one. So let's do CLF2.score. And inputs are these. Outputs is DF species, or the desired outputs, I should say, is DF species. So now we went up from 75% accuracy to 95% accuracy. And let me show you where this 95% comes from. So I could do CLF2.predict. Okay, and this gives me outputs like I predict Adelie, and so on. And so I could ask, how often is that actually equal to the true value in the species? So here I get a Boolean NumPy array. And let's see, maybe I'd like to keep the original one. So let me just display that again. Okay, so all 10 of these that I can see for now are trues. And if I just want to know like what is the proportion of these that are true? Well, there's like a tricky way to get this, which is I can just take the mean of this NumPy array. And the intuition behind that is it's like adding up all of these where it's counting true as 1 and false as 0. And then it's dividing by the length 333. And so that's going to be the exact same as how often was it true. Okay, divided by 333. And here's this exact same 95.8% chance that we saw up above using this score method.